Some questions about exponential work right now. I had thought maybe you guys had done some exponents last year in 7th grade, but maybe not as much as what I would have liked for this algebra class. We may have to spend a couple of days on this to make sure we understand it, because this is huge for you to come out of this algebra class with exponential knowledge with these problems. Okay, now, first things first, number 3, scientific notation, folks. All scientific notation is, if you want to get down to brass tacks with it, 3 times 10 to the 13th power is telling me that I'm taking the decimal point. There isn't one there. There's always a decimal point afterwards. I really don't like this way of writing scientific notation. It should be 3.00 times 10 to the 13th, but that's neither here nor there, okay? That's just my personal preference on how to write it. That way you don't have any worries about where the decimal is. But 3 times 10 to the 13th power is basically just saying this decimal point moves 13 times, and because it's positive, it moves 13 times to the right. So it would just be 3,000,000,000,000. Okay, it's just a huge number. It's a way of writing monstrous numbers or tiny numbers without having to put all the zeros in there. Now, when they take scientific notation and you're actually doing work with it, like in this case, I'm taking 3 times 10 to the 13th times 8.2 times 10 to the 11th. I have this in the other video. With this type of problem, all you're doing is taking the number out in front, 3, and the number out in front, 8.2, and you're multiplying them, okay? 8.2 times 3. 3 times 2 is 6. 3 times 8 is 24. The decimal point goes there. 24.6. You multiply the big numbers out in front. Now, because it's a multiplication problem, the exponential values, all you do is add the exponential values. So 10 to the 13th, as long as they're the same, 10 to the 13th, they're both 10s, 10 to the 13th plus 10 to the 11th. 10 to the 13th and 10 to the 11th make times 10 to the 23rd power. 24.6 times 10 to the 23rd power. Now, I don't like the way this is written, okay? This is not scientific notation. If they say to write this expression or simplify the expression, they also want you to simplify it so it's in correct scientific notation. Now, what it means by correct scientific notation is it's not 24.6, it's 2.46 times 10 to the whatever power, okay? And that's what we have to figure out. This is telling me I'm going to move this decimal right here 23 places to the right. To the right because it's a positive 23. But this decimal point is here. I need to move it 1 place to the left so it's written correctly. Now, if I move it 1 place to the left, that means I've got 1 extra jump to make for it to be in the correct place value once I've moved it the correct amount of times. So it's not 23 jumps to the right because I moved it 1 more to the left. That means it's actually 24. So it's 2.46 times 10 to the 24th power. That means I'm taking the decimal point and moving it 24 times to the right. Now, how could you have done this differently? You want to see how you could have done it differently? Convert both of these into standard form and then do the work they tell you to do. Convert 3 times 10 to the 13th into 3 with 13 30 billion. That's what 3 times 10 to the 13th. That's telling you it's moving the decimal point 13 places to the right. Now, this is 8.2 times 10 to the 11th. 8.2 times 10 to the 11th means I'm taking the decimal, moving it 11 places to the right. So it's going to be 82 with 10 zeros. All right. Looks fun to you? I don't really like it. Okay. This is 820 billion times 30 billion. Yuck. No, thank you. Oopsie, I did something wrong. Should be 30 trillion. Yeeks. Because it's moving 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 places to the right. I only moved it 9 or 10. Now, do you want to do that multiplication? 3 times 82, which I did up here, is 246. But then you've got to add all those zeros onto it, and it's going to be 246 with 23 zeros after it. No, 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 not a chance. I don't want that. Okay? That's why using scientific notation is substantially easier. When it's multiplication, all you do is add the exponential values. If it's division, you subtract them. Okay? And then do the regular work with the numbers out in front. Now, on down to numbers 6, 8, and 9. Numbers 8 and 9 are simplifying exponential expressions. Okay, I went over this on the video as well. Okay, the earlier videos. I've got like 3 videos out on this stuff. This is going to be my 4th or 5th. Simplifying exponential values. When you do a problem like this, it's a multiplication problem. 2b to the 4th to the 3rd. 2b to the 4th all to the 3rd power times 12b to the 9th, w to the 0, a to the 4th. Okay, you've got to get rid of the parentheses first. 2b to the 4th power all to the 3rd power. That means everything in there is to the 3rd power. Each piece is to the 3rd power. 2 to the 3rd power. And I did this very problem in the video, I'm pretty sure, one very similar to it. 2 to the 3rd power means 2 times 2 times 2. 2 times 2 times 2. That's 8. B to the 4th to the 3rd just means b to the 4th times b to the 4th times b to the 4th. Adding all those up, it's b to the 12th power. Okay? Another shortcut is take the big number, the coefficient, to the exponent, 2 times 2 times 2. Take the exponential values and multiply them. That's all it is. Okay? So you've got 8b to the 12th times 12b to the 9th, w to the 0, a to the 4th. I'm going to tell you right now, w to the 0, goodbye. Anything to the 0 power is just 1, so I don't even need you in there. You're just a place filler that's trying to mess me up. Okay? Coefficient times coefficient. 8 times 12. 8 times 12 is 96. That's your coefficient. Are there any like variables in here? A b to the 12th and a b to the 9th. Add the place value, or the exponential value. 12 plus 9 is b to the 21st. You're done, you're done. And what's left? A to the 4th power. Now you could put that w to the 0, but you don't want 0 exponents in an answer, and you don't want negative exponents in an answer. So getting rid of the 0 exponents and getting rid of negative exponents makes your life a lot easier. Now, I'm pretty certain I did the division problem. This is the one, number 9, that I did in the video earlier. Go back and look at the video for number 9. It's in there. I do a problem. I do this one right here. It's done the same way. You've got that 2j to the 1st, k to the negative 5th, all to the 3rd power. And then you've got times jk to the 2nd power. I'll do that one later, but I want you to try that one. It's a division problem. It's not that bad. I will talk to you later. More to come.